Okay, yesterday we left off. We had done everything that I wanted to do except example 5. And so today I wanted to pick up and talk about example 5. And this was the vector projection that I didn't get to talk about. So if you look there, we have a little bit of a definition. And it talks about a vector is projected onto another vector by dropping a perpendicular vector from one vector to the other. To find the projection of u onto v, we use this formula. Now, I will say there's a slight typo here in the formula, just in how it's written. And it should be, it's the projection of u onto v. And so when we write that, it is the big U and the little v. Or the v is what I would say is subscript. Does that make sense if I use the word subscript? It's that little type. And that's just the notation. But again, this notation stands for projecting a vector, a projection of u onto v. And so it is key to catch that it says u onto v. Now, to give you a little visual, I'm going to go back up here, just because this is where I have an open space. But the idea here is if I have a vector v, I'm going to call that vector v, and I have a vector u. I'm going to call this vector u. So if a vector is projected onto another one by dropping a perpendicular vector, the idea that in order to drop u onto v, you would drop it where there's a right angle here. And so then your new vector u would be right there. And that is what I would call u1, okay? Because once you drop that vector, we can't have multiple vectors u's. So we would call it u1. It's a projection of u. So this is a little bit of a visual of what we're talking about here. When you have u projected onto v, it drops with a perpendicular vector from one to the other. And this formula right here, the projection of u onto v, which is u times v over the absolute value of v squared, and then times vector v, that formula is how we're going to be able to find that projection. So in other words, find that u1, or what that new vector is. Okay? So example 5 lets us practice with that a little bit. And example 5 in the notes is just like, what was it, 25 and 26 in the homework that I said you couldn't do yet? It's exactly what you're going to see there. So let's look at example 5. Find the vector projection of u, which is 6, 2, onto v, which is 5, negative 5. That's the first thing we're going to do. And then we're going to be asked to write u as a sum of two orthogonal vectors, one of which is the projection. So let's worry about the first part. Find the vector projection of u onto v. And so when we do this, I'm going to call it u1. And we're going to use this formula we were just given, where it's the projection of u onto v. And in order to do that, we're going to use u dot v over the absolute value of v quantity squared, and then times vector v. So right there, that more than anything was me just writing the formula. And then we're going to fill in the formula here. So on top of that fraction, it says u dot v. How do we do u times v? We learned it yesterday. How do I do u times v? Okay. Yeah. First times first plus second times second. So 6 times 5 plus 2 times negative 5, right? Okay. I'll clean that math up here in a moment. Denominator. how do we do the absolute value of v? Okay. So officially this is the length or magnitude formula, right? Which officially is the square root of, it's listed as v1 squared plus v2 squared if you go back to lesson 6.1, isn't it? So officially we're doing the square root, and this is of v, right? So this is going to be the square root of 5 squared plus negative 5 squared. But then what's it say to do with this absolute value? Square it. Okay, and then I'm not going to write in vector v yet. I'm just going to put a times v, and we'll fill in v after we get this fraction dealt with. So numerator, 6 times 5 plus negative 2 times 5. 20, because 30 plus negative 10 is 20. Denominator. So under the radical, I have 5 squared plus negative 5 squared. Okay, it's 25 plus 25, which is 50. So it's the square root of 50, and then we have to square it. So it's just going to be 50, right? When you square a square root, you get whatever's under that radical. And so that's just going to be 50. And then officially it is times v, yes? What do you know about 20 over 50? Yeah, reduces to 2/5. I would never leave 20 over 50, right? Divide by 10. Cancel those zeros. So it's 2/5. And then if I fill in vector v, that means we're going to do times the vector 5 comma negative 5. How do I multiply that 2/5 times that vector, which is 5 negative 5? Distribute. Basically that 2/5 multiplies by each part. What is 2/5 times 5? Right? If you think of this as 5 over 1, 2 over 5 times 5 over 1 is going to become 2. What about 2/5 times negative 5? Negative 2, because 2 over 5 times negative 5 over 1. 5's canceled, and this is negative 2. So right there, that is our projection. That is what we found U1 to be. 2, negative 2. Questions on that part? Because that's technically only the first part of the problem. Now, in my brain, that's the harder part. I don't know. This other part might be equally as hard to you, but in my brain, that was the more difficult part. So on part 1, we were asked to find the projection of U onto V. Okay, done. And we called that U1, correct? The second part says, then write U as a sum of 2 orthogonal vectors, one of which is the projection. What did we call that projection? Yeah, this was U1, wasn't it? Should have just drawn that arrow over there. That's U1. So we're writing U as a sum of 2 vectors, one of which is U1, so 2 orthogonal vectors. So the idea that I would suggest you think here is that U is a sum of 2 orthogonal vectors, one of which is U1, and then what's going to be a good name for the next one? U2. So our goal is to write U as 2 orthogonal vectors, U1 plus U2. Now, what do we know out of this statement? We know U1, yes. We don't know U2, do we? But we do know, weren't we given U? We were given U. We just found U1. Could we use U and U1 to find U2? subtract u1 from u. Sorry, it's a lot of u's in there. It sounds weird, but is it making sense though? It does sound weird. I'm not going to lie there, okay? So if you just think of this like a basic equation, how do we solve for u2? We're going to subtract over the u1, right? And so when we do this math, we're going to be doing u2 is going to be u minus u of 1, or u1. So fill in the pieces. Let's find u2. Should have left myself a little bit more room there. U was the vector 6, 2 minus u1, which is the vector 2, -2. How do we subtract vectors?
Sorry, it's like 6 minus 2 and 2 minus negative.
See, looking, I can take it
Yeah.
too.
Like first minus first, second minus second. It's kind of like x minus x and y minus y. Yeah. So first component minus first and second minus second. So 6 minus 2 is 4. 2 minus -2. Yeah, because it comes to 2 plus 2, which is 4. Okay, what is this 4, 4 I just found? u2. And we were being asked to write u as a sum of two orthogonal vectors, right? We were being asked to write u as u1 plus u2. All I'm doing is writing it out here. We found u1 in the previous step, the projection, right? Did I just find u2? Yes. So all I'm going to do at this point is to write that u is equal to, and I'm going to write what u1 and u2 are. So I'm writing u is u1, which, what was u1? 2, -2, plus, what's u2? That's the 4, 4 we just found. So this is satisfying the second part of the problem. Okay, so we found that the projection was u1. We found that first. After we found that, we knew u. We used that to find the other part of the two orthogonal vectors. And then we were able to just write it as a statement. That u is this 2, -2 plus this 4, 4. Okay, and the idea is that those are orthogonal. They would meet at a right angle. Because you remember what orthogonal meant from yesterday, right? I guess I never reviewed that, did I? Orthogonal? Yeah, it says, what did it say? Almost the same as perpendicular. So pretty much meeting at a right angle. Okay. You should have done homework last night, right? But you have 2 problems left to finish. Give those a try. And I will come around and check homework here in a little bit, but give those a try and see what you can do with them.